Let y equals f of x equals x to the fifth minus 3x to the fourth plus x. Find the second derivative. So let's find the first derivative first, because we can't jump to the second derivative. So let's start with first derivative. X to the fifth power will give us 5x to the fourth minus 3x to the fourth. That's going to give us minus 12x to the third. And lastly, this plus x, that's plus 1x, right? The derivative of x is 1. So we found the first derivative. Let's do this one more time, but from this line that we just created. Let's find the second derivative. Do 5 times 4 to get 20 as the new leading coefficient. The new exponent is now down to 3. I have to do 12 times 3 to get negative 36, and the new exponent is down to 2. Derivative of 1 is just 0, so I don't have to put plus 0, and this is the second derivative of this example, okay? We have different ways to write f double prime, and that's what I used here. If f prime is the first derivative of f of x, if I put double prime, that's the second derivative. Now, I don't know, have I seen this, like triple prime? But after a certain point, you just put notations like this, like third derivative or fourth derivative. But there's another way to do this notation, the Leibniz notation. Okay, so like take a look at this one for me. This is the second derivative notation, okay? So this is talking about the second derivative of y. I'm done reading the numerator. The second derivative of y with respect to x. Okay, with respect to x. Okay, so, sorry, it says it right here. The second derivative of y with respect to x. So look, if I want to write the third derivative, then that's going to be really similar to this. Look at the notation for me. So if this is the notation for second derivative, let's try to write the notation for third derivative. So you're going to write d. Instead of the 2, put the 3. So that is saying the third derivative of y with respect to x. So this is the third derivative. Just notation, okay, nothing difficult. They looked intimidating, but nothing bad. I like to keep my, prime notation. I'm probably going to just stick to these ones, okay? But if you see problems that are using this like different way of writing, the higher order derivative, we're still doing the same thing. We're just keep on finding the derivative of the derivative and just going down, okay?